Okay, so in this video we're going to have a look at a couple of problems involving forming and solving with quadratics. There's quite a lot of topics that are involved in both of these. I'm going to have a look at two questions, one that we're going to focus on non-calculator and one that we're going to focus on using a calculator. So grab a piece of paper, grab a pen, make some notes. We're going to have a look at this question to start with. Now, as I said, both these questions involve a lot of topics, and just looking at this one here, it says the diagram shows a trapezium. It says the area of the trapezium is 351 centimetres squared, find the value of x. Now, when it comes to this sort of question here, we have got a lot involved. Obviously, we've got a trapezium, so we're going to have to look at the area of a trapezium. So there's the first thing you need to know, the area of a trapezium formula. We also need to know how to form and solve equations, and in this case, as we've already mentioned, we're going to be forming and solving a quadratic. So when it comes to solving a quadratic, we need to know how to solve them. That's going to involve factorising and solving, so there's another couple of topics there. And then we're also going to have to understand a little bit of logic behind why we get the answer we do, or why we pick the answer we do, which we'll see in the final steps. So there's about 4 or 5 things involved there. And again, I'll link all those in the description below. So you might want to check out forming and solving equations. You're definitely going to want to make sure that you've checked out how to solve a quadratic by factorising. And then we'll discuss some of the other topics you're going to need in our second question. But I'll link those in the description. So if any of this you feel like you need a little bit more practice on, that's the place to go. So for this one here, let's have a look. Now it says that the area of the trapezium is 351, and that gives us a hint here that we are obviously looking at the area. But obviously the pieces that we're given here are in terms of algebra. We've got some expressions for the lengths. Now when it comes to the area of a trapezium, you take the two parallel sides and you add them together, and we call them a plus b. There we go. Once we got the answer to that, we halve it. So it's a plus b divided by 2, and then we times it by the perpendicular height, which in this case is our 2x over there, or times h. And that's how we're going to get the area of a trapezium. That can obviously be written in a slightly different way as well. You could write half brackets a plus b and then times h at the end, but I just like to write it in this particular way. So that's the format of, or the approach that I'm going to take here. So if we take our first two pieces, so let's get rid of this. Our two parallel sides here are the x minus 4 and the x plus 5. So first of all, we'll add them together. Well, we've got two x's, so we've got 2x there. And then we have a plus 5 and a minus 4, and combined that makes positive 1, so it's 2x plus 1. And that's the sum of our parallel sides. So we're going to have to halve that. So we'll write that over 2. And then we're going to times it there by the height, and the height over here is our 2x. So we're going to times that by 2x. Let's write that again. So we're going to times that by 2x, and then there's a couple of different ways that you could actually approach this part here. That's going to give us an expression for the area. We'll look what to do with that once we have it. But in terms of actually approaching this, we could divide the 2x plus 1 by 2 to start with, or we could times the numerator by 2x and then divide it by 2. It really doesn't matter which way we approach it. I'm going to times the numerator by the 2x, and then we'll look at halving it, rather than getting decimals involved with halving the 1. So if we times the top by 2x, we get 4x squared, so 2x times the 2x gives us 4x squared, plus, and then the 2x. And there we go, just 1 times 2x. And again, all I've done there is I've timesed both of these by the 2x. Now again, now that's done, it's still over 2, but that's just a little bit easier now, just for us to halve that nice and quick, and we should get our final expression here. So half of 4x squared is 2x squared, and half of 2x is 1x, so it's 2x squared plus x. So that is our expression for the area, okay? I'm going to get rid of that and write that bit again. There we go, 2x squared plus x. So that's our expression for the area. Now this is where we form our equation, because we've got our expression for the area there, 2x squared plus x, but we need to set that equal to the actual numerical area that we've been given here, which is 351. And that's going to form our equation. So now that we do that, we've got 2x squared plus x, and all of that is equal to 351. Now obviously this involves knowing about forming and solving quadratics here, because obviously in order to solve a quadratic it has to equal 0, and at the moment it equals 351. That's easy enough to make it equal 0. We'll just subtract 351 from both sides. So if we minus 351, we get 2x squared plus x minus 351 equals 0. And that's really the absolute essential for this question, being able to form this quadratic and getting it equal to 0. If you can get to that point, the rest is now just about practicing solving a quadratic, so being able to factorise this and get our two solutions from it. Now, to be fair, I've picked quite a nasty number here, okay, and this is where the difficulty really comes in this question. I think as long as you know the formula for the area of a trapezium, the earlier elements there aren't too bad. Adding together those two parallel sides, timesing it by 2x, and simplifying it down, setting it equal to the area. There's a lot of steps there, yes, but I think here is where the real difficulty comes in. It's solving this quadratic here. It's quite a nasty one. But if we get rid of some of this working out, we'll just focus on this quadratic now. Okay, so let's just move this up to the top and we're just going to focus on solving this quadratic, and it's not the nicest. Now, the reason it's not very nice here is because obviously the factors we're looking for, particularly without a calculator, are 351. So this is almost looking at really factorising a nasty quadratic as well. The one thing we do know is that in the bracket we're going to have a 2x and we're going to have a 1x. And we're looking for two numbers that multiply to make the 351, but also add to make 1 in the middle as we have a 1x there. Obviously one of these numbers is going to double. So we're looking for a pair of numbers where one of them doubles and they're only 1 away from each other. And it's pretty nasty there with 351, so we're going to have to apply some real kind of nasty sort of mental arithmetic here. Now, first of all, we'll look at that number 351. There's a few little tricks here to try and find an easy factor to start with. And once we get one factor, there's a little trick to kind of help us find some more. So 351, well, it's not even, so it doesn't divide by 2. So the next number I always try out is 3. There's a little trick to see if a number divides by 3, and that is just to add up the digits. So 3, 5 and 1 add up to 9, and that's in the 3 times table. So that tells us that 3 is definitely a factor. So we know 3 is going to be a factor, we just need to find the other one in the pair there. So obviously we can just do a bit of bus stop to the side to find this out, but obviously there is quite a bit of working out here just to obviously factorise, which we normally expect to be able to do in our heads relatively simply. So this one's quite a nasty one. So 351, if we divide that by 3, we get 1, 1, remainder 2, and then 7, so 117. Now if I double either of those, they're not going to be 1 away from each other, so unfortunately it's not 3 and 117, so we're going to have to go again. So again, looking at those pairs of numbers, and what we can do here is if we can divide or times, divide one of them by something, we can times the other number by that number, if that makes sense. What I mean by that is if we can divide 117 by 2, we could times 3 by 2, and that would give us another 2 pairs of factors, or another pair of factors. While 117 doesn't divide by 2, so again, let's have a think, does it divide by 3? 1, 1 and 7 adds up to make 9, so it's in the 3 times table, so it does divide by 3. So if we divide that by 3, we can times the 3 by 3. So 117, divide that by 3. 3 goes into 11 3 times, with a remainder of 2. Then it goes into 27 9 times, so 39. So if 117 divided by 3 is 39, then we can times the 3 by 3, and that would mean it's 9 times 39. A little bit of a trick here for finding pairs when you've got some nasty numbers. So another way, well, let's have a look. If we double that 9, that makes 18, so they're not 1 away from each other, so we're going to have to go again. So what about trying 39 divided by 3? Now hopefully you know that divides by 3. If we divide that by 3, we get 13. And if we times 9 by 3, we get 27. There's another pair of numbers, so 27 times 13. Now, if we double 13, that's 26, and they're 1 away from each other. So hopefully that should work there in our bracket. Let's have a look. So if we double the 13 over here, and stick the 27 over here, we're going to want to make positive 1. So we're going to want plus 27 and minus 26 when that gets doubled. And there we go, that is that factorised. I think that's the hardest element to this question here. So that is just obviously looking at factor pairs and actually a little process there in order to get there. And what we did was obviously we divided 117 by 3 to get our first one, and then multiplied the other side by 3, so did the inverse to the other side. And then we did exactly the same on the row below, divided by 3 on the right and times by 3 on the left. But there we go, we've got it factorised, so we've got our two solutions in the bracket here. So the right bracket's probably the easiest one there, it's just the opposite sign, so x equals positive 13. And on the left here, we have x equals, and it's going to be negative 27 over that 2 there, or minus 13.5. So there's our two solutions. We've got x has to be negative 27 over 2, or x has to be 13. And this is where the final step comes in. The final step here isn't too bad. It's just thinking logically about numbers. So looking at our trapezium over there, we have some lengths in terms of x. Now x minus 4 is one of them, and that's just one that I'm going to look at. We could look at any of them, but obviously x minus 4, if I was to put negative 13.5 in, taking away another 4 would leave us with negative 17.5. We can't have a length of negative negative 17.5. So what that tells us is that this solution on the left here doesn't work. We can't actually have that one. But 13 works. We can have 13 take away 4. That gives us a length of 9 at the top. We can do 2 times 13 on the left there. That gives us 26. And we can definitely do 13 plus 5 on the bottom. So that value there, x equals 13, is the only one of our two values which actually works in terms of this actual physical shape. So our final answer would be x equals 13, and that's just about picking out the positive value when you are solving these harder quadratics here. Now, not all questions are going to be that nasty with a number at the end that's so horrible like that, but obviously it's worth just exploring one of these kind of more unique questions where there is quite a nasty number and just thinking about a process of actually how to get there. But the majority of topics within this that I'd like you to obviously be happy with is obviously forming that quadratic, setting it equal to 0, and then the process of factorising and getting your solutions. But there we go, there's the first of our two questions. That's a very nasty one to do without a calculator. I would hope that would be a calculator question really, but if it wasn't, obviously there's a bit of an idea of how you would go about solving that. Right, let's have a look at our next and final question, and this one you are going to have a calculator for. Okay, so here's our second question. Now it says here the diagram shows a hexagon. The corners of the hexagon are right angles. So the corners that we're looking at here are all of these, so we've got some right angles involved. There we go, and that just tells us that basically it's made up of these rectangles. It says the area of the hexagon is 40 centimetres squared in a very similar fashion to what we had last time, obviously, but we don't have such a nasty number here with 40. And it says find the value of x and give your answer correct to 3 significant figures. Now for this one here, the hint here that we're going to be using a different kind of process is it says give your answer correct to 3 significant figures. So depending on what kind of equation is formed here, and obviously we are looking at forming quadratics, if we're going to give an answer to 3 significant figures, it gives us a massive hint here that we're going to be using the quadratic formula. Now if we look at this then, how are we going to create these expressions? Now we have one of two options. We can either cut this shape across the top and form a rectangle, two rectangles that way, or we can cut it going downwards and we can cut it down this way. And obviously if we remove this line, we've now got two rectangles that way. It doesn't really matter which way you do it. As I've finished off drawing it that way, I'm going to cut it that way, but we'll write the expressions for these two missing sides anyway, for obviously if you wanted to do it a slightly different way. So we've got two missing sides here. We've got this one here across the top there, and we've got this one going down the side. Now in terms of the expressions for those, the one going along, which we'll just have a look at to start with, we need to find that using the two horizontal lines. So we have the 4x minus 3 as the total length and 4 up here as part of that length. And if we do 4x minus 3 and take away that 4, we would be left with 4x minus 7, there we go, and we'll put that into a bracket. Now if we were to use the other little length going upwards, we would have to do the x plus 1 that we have over here, and we would have to subtract that from the 3x. And that's not particularly nasty to do. 3x take away the 1x would leave us with 2x, and 3x take away the 1 would leave us with obviously a minus 1 there, so we would have 2x minus 1 if we were to look at this vertical line just here. But as I said, we may as well only do it one way. There's no point in doing it both ways, but just so you are aware, you could do it either way there. It's completely up to you. Right, so let's actually just do it this way. Now we've got two areas that we need to find. We've obviously got the larger area for this rectangle here, which is going to be easy enough for us to find. The length is 4 and 3x, so 4 times 3x, which we can write down, gives us an area there of 12x. So that's the area of that larger rectangle. We also have this rectangle then on the left, and that rectangle on the left there is just going to require a little bit more working out because the two side lengths there are binomials. By that I mean we have these brackets. We have the x plus 1 and the 4x minus 7. So we need to expand a double bracket. So if we do that, we've got 4x minus 7, and we have x plus 1. And it's not particularly difficult for us to expand out, but obviously we've got expanding double brackets now, so we've got another topic getting involved. If we expand that out, 4x times x is 4x squared. I'm going to skip the middle step. We have 4x times the 1, which is 4x, and the minus 7 times x, which is minus 7x, and in total that combines to make negative 3x. Remember not to skip those steps unless you're super confident with that. We have 4x, take away 7x, and 4 take away 7 is minus 3, so it's minus 3x in total. And then multiplying those two numbers together, negative 7 times 1 leaves us with minus 7. So that's our expression for that little bit of the area. It's quite large, that one there, so I don't think I'll be able to fit it in, but we'll put it over here anyway. So we have 4x squared minus 3x minus 7. Can just about fit that in there. So to get the expression for the total area here, we need to add those pieces together. So we have the 4x squared minus 7x minus 3x minus 7, and also the 12x. And if we combine those, we need to add the 12x to that negative 3x. So if we add the 12x to that negative 3x, we're going to have positive 9x. So in total, we've got 4x squared plus 9x, obviously combining the negative 3x and the 12x, and then minus 7. Now that's our expression there for the area. Now just like the last question, it gives us a value for the area. It says here 40 centimetres squared. So we can set that equal to the 40 centimetres squared, just like we did on the last question with our 351. And if we bring that down, we can see that all of that has to equal 40. Now we've got a very similar process again, because again, we've got a quadratic and we've got to solve it, but it has to equal 0. So we need to subtract or minus that 40 from both sides. That's easy enough for us to do. So we get 4x squared plus 9x, and then it's going to be minus 47, and that's going to all equal 0. And obviously we've already mentioned this is going to be a calculator question. It gives us a hint there. It says give your answer to 3 significant figures, which means that this doesn't factorise. So if we're going to actually do this, we may as well just plug it straight into the quadratic formula. So if we get rid of some of this working out here, so we've got a bit more space, and we'll put that into the quadratic formula. Now obviously before you do that, you need to get your values of a, b and c. So again, a equals 4, b equals 9, and c equals that negative 47 at the end. And again, don't forget, obviously I'll link the video for the quadratic formula as well in the description, just to make sure that you're obviously nice and clued up on that. So I won't write down the quadratic formula because I'm going to assume that you're already happy with that. But if we plug the numbers in, we get minus b on the top. Don't forget x equals minus b on the top. So b is 9, so we have minus 9. And it's plus and minus the square root of, we have b squared, so 9 squared. And I always put this value of b in a bracket. Take away 4 times a is 4, so 4 times 4 times c, which is negative 47, so times negative 47. And all of that is over 2a, and that's 2 times 4, as a is 4. So there we go. That's plugged into the quadratic formula. Just need to type that into our calculator then, so pressing the fraction button, and then on the top, minus 9, we'll do the positive version to start with, or just using the plus symbol to start with. So when we use the plus symbol, the square root of 9 squared minus 4 times negative 47, making sure you use the negative button for that 47 and not your takeaway symbol. Might work on some calculators, but the majority it doesn't. And on the bottom there, 2 times 4. And our answer for that comes out as, oh, it's quite a long decimal here. We have 2.48271 and then 7422. There we go. And there's our first one. Now if we go back into our calculator then, change that plus sign for a takeaway, and we type it all in again. So with the minus sign there, we get negative 4 points, and again a long number, 732717422. So again we've got two answers. And obviously it says find the value of x, so there's only one answer to this question, and again we just need to think logically about these numbers, and it's the same process as before. If we look at one of the sides, it doesn't matter which one we pick, one of the ones with an x in, so what about this 3x just here? If we were to multiply that negative 4.7 by 3, we'd have over minus 12, we'd have, well, let's just multiply, what would we have? Minus 4.7 times 3, we'd have, you know, minus 14.1 and a bit more with those extra decimals. But obviously the concept there being that we can't have a negative length. So that negative 4.7 is not going to work as a solution for us. So it has to be this positive 2.48 number. Now obviously it does say to give your answer to 3 significant figures, so to finish this off we just need to round this, and again that process of rounding, we'll chop it after the third significant figure, so 248, and it's a 2 after the 8 there, so that's not going to round it up, it's just going to be 2.48 as our final answer to 3 significant figures. So there you go, as you can see, another type of question. We had some different things involved there. We had forming the side lengths, or the expressions for the side lengths. We had expanding a double bracket, multiplying expressions, forming a quadratic equation when we then set it equals to 0, solving a quadratic equation using the quadratic formula, and then again just using a bit of logic at the end. So a load of topics involved within this one, but again I will link them all in the description. for you to obviously explore a little bit further, and they'll be nice and clearly linked for you just down there. But don't forget to check those out. So there we go, there are our 2 questions looking at forming and solving with quadratics. Hope you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.